Good morning, friends. Welcome to the class of LCM and HCF. This topic is a part of number system, and this is a very basic topic that is used by the students in different aspect of arithmetics as well as number system. In this topic we use two terms. The first one is LCM, that simply means least common multiple. Second one is HCF, that means highest common factor. It means in this topic we are going to understand first what is the difference between the term multiple and factor. The first thing that we have to understand the difference between multiple and the factors. When we consider the multiples of a number are all those numbers that are divisible by the given number. For example, if I have to write the multiples of 5, my list will be 5, 10, 15, 20, 25, and that goes up to infinity. Number of multiples can be there. When we consider the factor, suppose one number is there 20 and I have to write all the factors of 20. I may write 1, 2, 4, 5, 10 and 20. These are the factors of 20. Now here we are concerned with least common multiple and least common factor. One thing we are sure that whenever we have to find the LCM means multiples. It means whatever my answer is there, that may be greater than the numbers given. It may be greater than or equal to the numbers given. In the second case, if we have to find the HCF, that is highest common factor will always be smaller than or equal to the number, right? So one thing is clear to you now. My LCM will always be more than equal to the given numbers and HCF will always be less than equal to the given numbers, because in LCM we are finding the multiples, in HCF we are finding the factors. Before going further, first of all we try to understand the traditional method to find LCM and HCF. First of all we understand the traditional method to find the LCM as well as HCF. For example, we have to find the LCM of the numbers. Numbers are given as 36, 42, 56. We have to find the LCM of the numbers. Now when I look at this question, what I can infer here? I can say that first I will take the smallest possible number that can divide all the three, that is 2, 18, 21, 28. Again 2, 9, 21, 14. Now 2 cannot be taken from at least two numbers. Then I will take 3 as common, 3, 7 and 14. Then I will take 7 as common, 3, 1 and 2. My numbers are 2, 2, 3, 7, 3, 2. And if I have to find the LCM, I may write my answer as 2 into 2 into 3 into 7 into 3 into 2. And my final answer is said to be 2 to 4 to 8, 8, 9, 72 into 7. My answer is said to be 504. That is said to be the least common multiple. So this is the first traditional method by which we can find the LCM of our numbers. Now for that we have one modern method that can be done with the help of the concept of prime factorization. We have one more method here for finding out the LCM. This method is based on the concept of prime factorization, right? What do you mean by the prime factorization? By the term prime factorization we mean whatever the number is given, we have to break the numbers in the powers of the prime numbers, right? All powers should be of the prime numbers. For example, suppose the number is given are 36, 42 and 56. In order to find the LCM by the way of prime factorization, the first step that we are expected to do, we make the prime factorization of the given numbers. 36 may be broken as 2 square into 3 square, that is 4 into 9, that is said to be 36. Then you have 42, it may be taken as 2 into 3 into 7, 6 into 7 is 42. Then we have 56, 8 into 7 we can say 2 cube into 7, that is said to be 56. Now the first step is, if we have to find the LCM by prime factorization method, the first thing we are expected to do, we have to factorize the given numbers. Now in order to find the LCM is take all prime numbers with maximum powers. What do you mean by that? What is the process to find the LCM with the help of the prime factorization method? The method is very simple. Whatever the numbers are given, first of all we have to factorize the number by the help of prime factorization. Now after doing the prime factorization, we have to find the LCM. We take all prime numbers. So my prime numbers are 2, 3 and 7, and power should be maximum. What is the maximum power of 2 here? 3. What is the maximum power of 3 here? 2. What is the maximum power of 7 is 1. So I can say this is 8 into 9 into 7. My answer is said to be 504. It becomes my answer. I hope the idea is clear. What the concept talks about, in any question, if you have to find the LCM of the given numbers, we have two approaches now. The first is our traditional approach. What this approach talks about, first of all, we write this number in such a way. First we take 2 common outside, then again 2 can be taken as a common. Finally, we can take 7. After that, no term can be taken as a common. Now multiply all these numbers, and after the product of the numbers, you get your answer as 504. That is said to be least common multiple of the given numbers. Similarly, when we apply the concept of prime factorization approach, in that, first of all, we have to factorize the given numbers. Suppose 36, 40 to 56. That makes me 2 square into 3 square, 2 into 3 into 7, 2 cube into 7. Now, in order to find the LCM, take all prime numbers with maximum power. Right? Here I can say the maximum power of 2 is 3, maximum power of 3 is 2, and 7 is 1. And my answer is said to be 504. That is the LCM of the given numbers. We will take one more example in order to better understand this concept of prime factorization. Suppose I say my numbers are 120, 150 and 200. We have to find the LCM of the given numbers with the help of prime factorization. Now first there is a need to find the LCM. 120 is taken as 2 cube into 3 into 5. 150 is taken as 2 into 3, 6 into 5, 30 into 5. We can say 2 into 3 into 5 square, and 200 is taken as 2 raised to power 3 into 5 square. That is 25 into 8. Answer is 200. Right? Now if you have to find the LCM, what LCM talks about? Take all the prime numbers. 1 is 2, 1 is 3, 1 is 5, and power of this prime number must be maximum. Power of 2 is 3, power of 3 is 1, power of 5 is 2. The answer is 8 into 3 into 25, right? Or I can say 24 into 25, answer is 600. So we can say LCM of our numbers is said to be 600. That becomes my answer, right? So this is the first thing, how to find the least common multiple with the traditional method as well as the prime factorization method. Now after this, we try to understand how to find the HCF, that is highest common factor. Now for finding the HCF, we will also apply the same approach. We have also here two type of approaches. The first one is traditional approach and the second one is prime factorization approach. Suppose 3 numbers are given. The one number is given as 288, second number is given as 432, and third number is given as 768. We have to find the highest common factor of the 3 numbers. Now in order to find the highest common factor, you may take any of the 2 numbers from here. That is in your hand, either you take these 2 or these 2. I am taking 768 and 432. That is a division method. Divide by 432. It will go on 1. I get 432. Subtract. You get 6, 3, 3. Again divide 432. Now this becomes the quotient. Now this becomes the divisor and this becomes the dividend. It will go on 1. 336. We get it as 96. Then I am getting as 336. Now it will go on 3. 3, 6, 18, 8, carry 1, 27, 1, 28. You have to subtract. That is 48. Right here 96. It will go on to 96. This is cut. Right? Here I can say HCF of these 2 numbers. I have taken these 2 numbers. HCF of these 2 numbers is said to be 48. Now if only 2 numbers are given, so this is a process to find out the highest common factor. Now in this question numbers given are 3. So next step what we will do, we have taken the HCF of these two numbers. Now I take this number with this. So I will make it as 282 and start to divide by 48. Right? Here when I divide by 48 it will go on 6 and you get it as 288. It means now finally I can say HCF of all the given three numbers is equal to 48. That becomes your answer. Try to understand the approach once again. What I have told you, in order to find the highest common factor, this method we use, that is known as the division method. By this method, what process you apply? You can take any two numbers from the given three numbers and we start to divide. Suppose I have taken the numbers as 432 and 768. First I am dividing this 768 by 432. It will go on 1, divide 432. You have to subtract, you are getting 336. Then again divide and so on until we get our final remainder to be equal to 0. So here I can say this is 48, means I can say highest common factor of these two numbers is said to be 48. Now after that, this is 48 and this is 288. Now I will take the third number and HCF of these two numbers. I divide by 48. It will go on 6. I get my answer to be 288 and this finally 48 is said to be highest common factor of the three given numbers, that is said to be 48. So by traditional method or by division method, we have got the HCF of these three numbers is said to be 48. Now after this, I am going to tell you the prime factorization method in order to find the highest common factor. Now after this, I am going to tell you prime factorization method in order to find the highest common factor. Now what this method talks about? First of all, you have to factorize. Suppose you have 288, 432 and 768. First of all, you have to factorize. How we can factorize? The process is very simple. Just think of any number that may divide it. So we can say that it can be divisible by 4. That will result in 72. We can make 4 as 2 square. 72 is taken as 2 cube into 3 square. Or finally I can say that is 2 raised to power 5 into 3 square. Right, there I can say prime factorization of 288 is said to be 2 raised to power 5 into 3 square. Similarly, we have 432, same, I will make it as 4 into 108, that would be 2 square. 108 is 12 into 9, or else I can say 2 square into 3 square, or here I will get it as 2 raised to power 4 into 3 raised to power 3. So that is the prime factorization of these two numbers, 2 raised to power 4 into 3 raised to power 3. Then we have 768 divided by 4. You get it as 192. 4 would be taken as 2 square. 192 is taken as 24 into 8. So I will take it as 2 cube into 3, 24 into 8, 2 cube. Or else I can say 3368, 2 raised to power 8 into 3. That is our third number. The prime factorization is 2 raised to power 8 into 3. I hope the idea is clear. First step is you have to prime factorize that we have done. Now I can say that we have to find the highest common factor. In finding the highest common factor, take all common prime numbers. The first step is take all common prime numbers and powers must be minimum. Here we have to take care of they must have minimum powers. What the method talks about? In case of finding the highest common factor, process is reversed. While finding the LCM, I told you, take all prime numbers and then power should be minimum. While finding the highest common factor, the concept is take common prime numbers and power should be minimum. Right? So what I can say now here, when I look at these questions, I may get that my common prime numbers are 2, 3. That is common in all the 3, make it as 2 into 3. And power should be minimum. So check out what is the minimum power of 2, here is 4. And what is the minimum power of 3 is 1. So that result means 16 into 3. My answer is said to be 48. My answer is the same as I got while using the division method. Try to check out it again what I have told you here. There are two methods for finding out the highest common factor. The first method is the division method and the second method is prime factorization method. How to use the concept of prime factorization? The concept is very simple. First of all, you have to make a prime factorization of the given numbers. After making the prime factorization, we write all the prime numbers here in such a way. Then the concept is take all common prime numbers. Here the keyword is common prime numbers, that is common in all the three. So when I look at these three questions here, so I may say that 2, 3 can be common, 2, 3, 2, 3. Means we can say that 2, 3 are common values, right here 2, 3, and power should be minimum. So here I can say the minimum power of 2 is 4 and of 3 is 1. So I can say 16 into 3, answer is said to be 48. So this is a method for finding out LCM and HCF. Now the second point that we have to understand, these things that I told you that can be applied where given numbers are integers. Sometimes the given numbers are fractions. For example, A upon B, C upon D and E upon F. You have to find LCM and HCF of these numbers. The three fractions are given and we have to find out what is the LCM and HCF of these fractions. In order to find the LCM and HCF, what we can apply in case of LCM, our formula is, you will note it down, it's a very important formula, and number of places this formula is used. In place of LCM, you may take it as LCM of numerators divide HCF of denominators. When you find the LCM, that is said to be LCM of numerator divide HCF of denominator. Similarly, if you have to find the HCF highest common factor, you may take it as HCF of numerator upon LCM of denominator. What the question talks about? How to find the LCM and HCF. LCM simply means that LCM of numerator by HCF of denominator, and if you have to find the HCF, you may use it at HCF of numerator upon LCM of denominator. For example, sometime you may get 1.8 to 2.4. You have to find the LCM and HCF. Suppose the three numbers are given. The first one is given as 1.8, second is given as 2, third is given as 2.4. You have to find out the LCM and HCF. In order to find that, first of all, we have to convert into the fractional form. I can say 1.8 is said to be 18 upon 10. This is 2. This is 24 upon 10. Or I may take it as 9 by 5. This is 2 and this is said to be 12 by 5. Then I can say this is 9 by 5, this is 2, this is 12 by 5. Now my fractions are there. One thing you have to take care of, you have to write into the simple form. Simple form means when something can be cancelled from numerator to denominator, you should cancel it, right? Now after cancelling this, I have got my fractions to be 9 by 5, 2 and 12 by 5. Now what LCM states? LCM states LCM of numerators means LCM of 9, 2 and 12 upon HCF of denominator, that is 5, 1 and 5. Right? So when I take LCM of 9, 2 and 12, so I can say LCM of 9, 2 and 12 is said to be 36. HCF of 5, 1 and 5 is said to be 1. I can say the LCM of these three fractions is said to be 36. Check out again what I have done here. The three fractions are given 1.8, 2 and 2.4. First of all, you have to convert into A by B form. In the simple form, so you may take it as 9 by 5, 2 and 12 by 5. Now, in order to find the LCM, you know that LCM is said to be LCM of numerator by HCF of denominator. So first we are taking numerators, that is 9, 2 and 12. Take 9, 2 and 12, you will find LCM is equal to 36. And HCF of 5, 1 and 5. HCF of 5, 1 and 5 is 1. So here I can say the LCM of these three fractions are 36. Similarly, if you have to find the HCF, so in order to find the HCF, you may say that HCF of numerator means HCF of 9, 2 and 12 upon LCM of 5, 1 and 5. Right? Now if you have to find HCF of 9, 2 and 12. So what is the HCF of 9, 2 and 12? That is said to be 1 because nothing can be taken common from all the three. So I can say HCF is said to be 1. Similarly, when I take LCM of 5, 1 and 5, that is said to be 5. This is 1 by 5, or I can say 0.2. So this 0.2 is said to be HCF of the given three fractions. So what we have understood here, first method that I told you, that is used when my given numbers are integers, and the second method that we are using here, that is used when given numbers are given as a fraction, and in order to find the LCM and HCF of the fractions, LCM is said to be LCM of numerator by HCF of denominator, and for HCF you may take it as HCF of numerator by LCM of denominator. After understanding of how to find out LCM and HCF, the next point that we are going to discuss, that is about different properties of LCM and HCF. When we start with the different properties of LCM and HCF, we take it one by one. The first that we use, product of two numbers is always equal to LCM of numbers into HCF of numbers. Suppose two numbers are given to you, so what we can say, the product of two numbers is always equal to LCM of two numbers and HCF of two numbers. Second property is HCF always divides given number exactly. HCF always divides the given number exactly. Third one is, it's a very important case. Suppose HCF of two numbers is given, HCF of two numbers is given, that is equal to x. HCF of two numbers is given, we can assume it to be equal to x, right? And we have to assume the numbers. So what assumption we can make if you have to assume the numbers? You can assume the numbers as XA and XB. Suppose HCF of two numbers is given as x and you have to assume the number. You can assume the number as XA and XB, where AB are co-prime numbers. Now here there is a need to understand what do you mean by the term co-prime numbers. By the term co-prime numbers means whose highest common factor is equal to 1, or we can say nothing can be taken outside from these two numbers except 1, right? So I can assume that if HCF of two numbers is x, so where we can assume that numbers can be assumed as XA and XB. Similarly, if you have to find out LCM of these two numbers, so that is said to be XAB. This is said to be XAB. Why? Because x is common in between them. In the LCM we will take that, and A and B both are co-primes to each other, hence we make it as AB. So I can say LCM of these two numbers is said to be XAB. These three are very important properties from the point of view of the concept of LCM and HCF. Number of questions can be framed from here. Suppose if I start with a statement, after understanding of basic properties, we can start with some of the questions here. Suppose it is given that LCM of two numbers is 120 and HCF of these two numbers is 15. Suppose one number is given as 45. The question is, we have to find the other number. Find the other number. That is your question, right? So when I look at this statement, I can apply my property number 1. What does it say? LCM of two numbers is 120, HCF is 15. LCM of numbers into HCF of the numbers, that is 120 into 15, is always equal to product of the numbers. We can assume the second number to be equal to A. So I can assume that, I can say that 120 into 15 equal to 45 into A. Just solve it, it will go on 3. 3 will go on 40. So I can say X is equal to 40. It becomes my answer. So I can say that if my one number is 45, the second number must be equal to 40 as per to the given information, right? But here, can I say my answer is said to be 40? No. Why? Because the one point is here that we know that HCF also always divides my given number exactly. Suppose HCF is equal to 15. If my answer is 40, it means 40 must be a multiple of 15. But here I can say it is not a multiple of 15. Hence, I can say my answer is wrong. So in this question, no such second number is possible. No such number exists. Why I stated a question here? Because most of the students simply mark their answer as 40. But at the end, we have to again check out that whether this 40 is divisible by 15 or not. If it is divisible by 15, then we can say that's our answer. But here it is not divisible by 15, so I can say no such number exists. Whose LCM is 120 and HCF is 15, and out of that one number is 45. I hope the idea is clear. So by this structure, we are in a position to get our answer. Now we may solve some questions which are based over these properties so that you may better understand the concept. It is given that LCM of two numbers is 196. LCM of two numbers is 196. HCF of these two numbers is equal to 7. LCM of two numbers is 196. HCF is 7. If difference of these two numbers is 21, if difference of these two numbers is 21, what is given to us? The difference is 21. We have to find the larger number. The question is, we have to find the larger number, right? Now when I look at this question, what does it gives us? LCM is 196, HCF of these numbers is equal to 7. The difference is 21, we have to find the larger one. I told you, when HCF is given to you, you can assume your number. You can assume your number as 7x and 7y, where x and y both are said to be co-prime to each other. That's the first condition. X and y are said to be co-prime to each other. Now, if my numbers are 7x and 7y, so I can say LCM of these numbers is said to be 7xy. And in the question, LCM is given. So I can say 7xy is equal to 196. From here, I can say xy would be taken as 196 upon 7. That would be taken as 7 to 14, 56, 8. So we can say xy is equal to 28, right? Now we have to make the pairs where product of the two numbers is equal to 28. So I can start with x is 1, y is 28, x is 2, y is 14, x may be 3, 4, 4, y is 7, 5, 6, 7. Again it will be reversed. That will be taken as 7, 4, 14, 2 and 28, 1, right? Now we know that these are the pairs of x and y that we have got here, right? Now the condition for us in the question is both x, y must be co-prime to each other. Now we try to find out what are the values which are co-prime. 128, yes, they are co-prime. I can say if x is 1, y may be 28. The second pair is 2, 14, they are co-prime, yes or no? No. 4, 7, they are co-prime. The second pair I can take, that is 4 and 7. Right, or it may be 7 and 4. Now if I take these numbers, so I can, from here I can find out my possible numbers. If I take x to be 1 and y to be 28, my possible numbers are 7x and 7y. So I may take it as 7 and 196. That's my first pair of numbers. And second pair, that is 4 and 7, so I can say my numbers are said to be 28 and 49. So if the question is how many such pair exist, I may say there two pair exist. If you have to find your numbers, you may say either your number is 7 and 196 or 28 and 49. Now as per to the given question, it is given that the difference between the numbers is 21. So we will try to find out of these given pairs, which pair has the difference to be 21. If I check out my first one, 196 minus 7, the difference is 189, it's not my answer. But when I check out here, 49 minus 28, the difference is 21, so I may say this is my final answer. Right? Means what I can say here that the question may be 2 or 3 types. The first type simply talks about you may have to find how many different such pair exist. In those questions, we have to just solve the question up to this point. Then we try to find out the different pairs. Out of this, we have to take the co-prime pairs. For example, 128 is co-prime. This is not co-prime. It means this have to be eliminated. 4 and 7 is co-prime. So I may say there are 2 such pairs, and if I have to take the ordered pairs, my answer is said to be, if I take 2 ordered pairs, my answer is said to be 4. But sometimes the question is different. In these questions, he may give you some additional condition, like for example, here it is given that the difference between the two numbers is 21. We have to find the larger number. In that case, we may make the pairs of such type, and here I can say larger number is said to be 21. We may take one more example here of this type so that the concept will be clear to you. One more question is there. It is given that HCF of two numbers is 6. HCF of two numbers is 6. Second condition is given, product of the numbers. Product of the numbers is 4320. The question is, we have to find out how many such pair possible. How many such pairs of number exist. Right? Now when we look at this question, HCF of the numbers is given. It means you will start from the point, assume your number as 6x and 6y, where x and y both are said to be co-prime to each other. That is the first step from where you can start. Earlier I told you, whenever HCF is given, you can assume your number as 6x and 6y, and after assuming the number as 6x and 6y, you may take your number as, when xy are said to be co-prime. Then take the second condition. The product of the number is 4320. So here you can say 6x into 6y, the product is equal to 4320, or else I can say x into y equal to 4320 upon 6 into 6. Just solve it. It will go on 6, 7, 42, 720 upon 6, or it will go on 120. Here I can say xy is equal to 120. Now the next point is, we have got here xy equal to 120. Now we try to make the different pairs for x and y, where x and y equal to 120. Because in this question we have to find the pairs. If we have to find the ordered pairs, then we take starting from 1 to 120. Because we have to find the pair, we try to count up to when it started to reverse. First pair is 1 into 120, 2 into 60, 3 into 40, 4 into 30, 5 into 24, 6 into 20, 8 into 15, 10 into 12. Again it reverses, 12 into 10, 15 into 8, 20 into 6. Because in the question I have to find the ordered, I have to find such only pairs. It means I will take the question up to this point. Now I cannot say my answer is 8, because these are the different possible values of x and y, and we know that the condition is given as x and y are said to be co-prime to each other. Now if I say x and y are co-prime to each other, so what I can say, 1 and 20, it's a pair of co-prime numbers? Yes. 2 and 60 is a pair of co-prime number? No, because HCF of these numbers is 2. 3 and 40 pair of co-prime number? This is not a pair of co-prime number because HCF is 2. 5 and 24 pair of co-prime number. 6 and 20, it's not a pair of co-prime number. 8 and 15, it's a pair of co-prime number. 10 and 12, it's not a pair of co-prime number. Means what I can say now, 1, 2, 3 and 4. So I can say in this question we have 4 pairs of co-prime numbers. Hence I can say 4 such pair of numbers exist. I can say that 4 such pair of number exist. That becomes my answer. I hope the idea is clear. These type of questions may be asked on the concept of properties of LCM and HCF. Now after understanding the properties of LCM and HCF, the next thing that I want to discuss here, this is about application of LCM and HCF.